Okay, this short video is on solving trigonometric equations with quadratic factors in them. So, they're equations that have trigonometric functions in them, sine, cosine, cosecant, and so on, all these different trigonometric ratios that we've looked at. And also, some of those terms will be quadratic. So we're going to use the quadratic formula to solve them, which we're hopefully familiar with. But remember that when we're solving equations that involve trigonometric functions, there are many solutions because the trigonometric functions are periodic. So in other words, there are an infinite number of solutions. So if my solution example for one was that theta or x turned out to be around about 40 degrees, then there would be another angle with the same sine, another angle with the same value for the sine, and so on. So there are many solutions, and if you remember, we need to usually quote a range over which we're interested, and normally that's between 0 and 360 degrees. So you're going to focus on that area and come up with solutions for these equations within that region. So the first example, solve this. So if we look at it, like any equation, half cot squared y equals 1.3, we try and get y on its own. Remember too that the cotangent, or cot for short, is 1 over the tangent of theta. So we're going to use that fact to help us put it in terms of the tangent function, which we're more familiar with and which the calculator will allow us to calculate. So, looking at this equation, a half cot y equals 1.3, multiply both sides by 2, and we get cot y, or cot squared y rather, equals 2 times 1.3, which is 2.6. So, remember, cot squared y is actually just a shorthand way of saying the cot of y all squared is 2.6. So square root both sides, we get cot y is the square root of 2.6. So y equals plus or minus 1.61. That's really significant figures. Cot y equals 1.61 plus or minus 1.61. But remember, cot is the inverse of tangent. So if we invert this, we get the tangent of y is the inverse of 1.61, which is 0.62. So y equals the tangent inverse tan of 0.62. Y equals 31.8 degrees. So now we want to have a look at the tangent function here, and see what other values, what other angles will give us a tangent of 0.62. So we look at the tangent wave, which is here, and we're interested in the region between 0 and 360 degrees, which is here. And if we look at our answer, which was 31.6 degrees, if I remember rightly, 31.8 degrees, then 31.8 degrees lies around about here somewhere. 31.8 degrees. So the tangent of 31.8 degrees is 0.62, and so if I went across to here, I'd get 0.62. But that's not the only angle whose tangent is 0.62. If we look here, there's another one here. and there's another one here, and so on. But we're only interested in the values between 0 and 360 degrees. So we're actually interested only in this value here, because this next one is actually beyond 360 degrees. So to get that, we look at the symmetry of the function, and you'll see that this wave is exactly the same as this wave. So if that's 31.8 degrees further on than 0, then this will be 31.8 degrees beyond this point, and this point here is 180 degrees. So it's 180 plus 31.8, which is 211.8 degrees. So we have two angles, two solutions for this particular equation. So for the original equation, theta equals 31.8 degrees or 211.8 degrees. Let's look at another example. Solve the equation 8 sine squared theta plus 2 sine theta minus 1 equals 0. So in this particular example, we let the trigonometric function sine theta equal x. And so if I were to replace sine theta by x in the equation above, I'd get this. Therefore, 8x squared plus 2x minus 1 equals 0. And now, hopefully, it looks like a familiar quadratic equation to you. Note that the right-hand side must be 0 for us to be able to apply the quadratic equation. So if the right-hand side is not 0, we need to make it 0. And then we just solve the quadratic equation as normal. And remember, when we solved it, that x is actually the sine of theta. So then we can work out what theta is and look for values of theta between 0 and 360 degrees. So if you care to have a go at that, then you could perhaps have a look at this work problem afterwards. So the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And in this particular example, a equals 8, b equals 2, and c equals minus 1. So putting those values into this quadratic formula to get x equals minus b, so it's minus 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c. But if we look at c, c is negative, so minus times by a minus will give us a positive. So we end up with plus 4 times a, 4 8 to 32 times c is 1. So we get 32 all over 2a, 2 8 to 16. So x equals minus 2 plus or minus the square root of 36 over 16. Square root of 36 is 6. So x equals minus 2 plus or minus 6 over 16, which is minus 2 plus 6 is 4. 4 over 16 is a quarter. Or minus 2 minus 6 is minus 8. Minus 8 over 16 is minus a half. So x equals a quarter or minus a half. But remember, x is sine theta. So therefore sine theta equals a quarter or 0.25. Or sine theta is minus a half. So therefore theta is the inverse sine of 0.25, 4, theta is the inverse sine of minus a half. So theta equals 14.5 or minus 30 degrees. So now, looking at these values, 14.5 and minus 30, we've got to look for values of theta within the range that we're allowed, 0 and 360 degrees. So we go to our sine wave, which is here, and we've got minus 30. So minus 30 is going to be around about here somewhere. And plus 14.5 around about here somewhere. So now we look for values of theta within that range of 0 and 360 degrees. So minus 30, we extend this along here, we're actually after that angle and that angle. For the 14.5, we're interested in the 14.5, but also this angle here. The one over here is actually beyond 260, so we're not interested in that one. So now we can work out from the symmetry of this wave what these missing angles are. So if we look at this, minus 30, we're going back 30 degrees from 360, which is 330. So we can say this one is 360 minus 30, which is 330 degrees. This one, we'll again look at the symmetry. We're at 180 plus this distance of 30 degrees. So 180 plus 30 is 210 degrees. And 14.5, this distance here, 14.5, then we need to go back 14.5 in this way. So 180 minus 14 is 166, so 165.5. So we've got 1, 2, 3, 4 angles that lie within our range of 0 and 360 degrees. If we think about this problem just before we leave it, why are there 4 solutions? 4 solutions to this equation. It's to do with this rotation. So if we think about our answer, we've got sine is 14.5 degrees. So if we look at the first one, 14.5 degrees takes us to about here somewhere. But that sine, which gives us 14.5 degrees, another sine tells us this side here. Then if you look at it, there's actually another angle, which is 180 minus 14.5, which is actually where we got this angle from here, 180 minus 14.5. If we look at the other angle, which is 210 degrees, so 210 degrees gives us this particular angle here, but so also does this angle here, which is 360 minus that 30 degrees. So you can see from the rotation how we get more than one solution. Let's have a look at another problem. 5 cos squared t plus 3 sin t minus 3 equals 0. In problems like this, we have 2 separate trigonometric functions within our equation. So what we need to do is get them the same. We need to have either all sine functions or all cosine functions. And because we've got the cos squared term, then actually we'll use these identities. And you remember there are 2 others that involve the cot and the secant and so on. And so in this particular case, this is going to come in handy because looking at this, you can replace cos squared theta with something. If we move the sine squared theta over the other side here, then we can substitute sine squared theta instead of cos squared theta here, and then we'll have all sine terms, and we've got a similar problem to the one we just looked at. So that's the way to approach it. See if you can work it out for yourself. The solution appears below. So first step is to say cos squared theta, therefore, is 1 minus sine squared theta. So in our particular equation, we can replace cos squared t with 1 minus sine squared t. Plus 3 sine t minus 3 equals 0. And then we'd expand out the brackets. 5 minus 5 sine squared t plus 3 sine t minus 3 equals 0. Now collecting like terms, 5 minus 3 is 2. So we've got minus 5 sine squared t plus 3 sine t plus 2 equals 0. Not essential, but at this point I would actually multiply through by minus 1 to get rid of the negative 5 here and make that positive. That will help, I think, when we look at substituting into the quadratic formula. So 5 sine squared t minus 3 sine t minus 2 equals 0. So now we have a equals 5, b equals minus 3, c equals minus 2, and we're going to substitute those into the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. Just being a bit careful of signs when we put them in. So x equals minus b. Well, b is minus 3, so minus 3 gives us plus 3. Plus or minus the square root of b squared. B is minus 3, minus 3 squared is 9. Minus 4ac. Well, again, we've got a minus multiplied by a minus 2, 4ac, because c is minus 2. So we end up with plus 4 times a, which is 5, 4 5s are 20, times 2, which is 40, all over 2 times 5, which is 10. So x equals 3 plus or minus the square root of 49 is 7 over 10. So x equals, remember what x is sine theta. So therefore, sine theta equals 3 plus 7, which is 10 over 10, which is 1, or 3 minus 7 is minus 4 over 10, minus 0.4. So sine theta equals 1 or minus 0.4, or sorry, should I say in this case not theta plus t, but t. So therefore t equals sine to the minus 1 of 1, which is 90, or sine to the minus 1 of minus 0.4 minus 24 degrees to the nearest degree. So now again, we've got to put these values of theta and into the wave function and look for all the angles that will lie within our range of 0 and 360 degrees. So the 90 is this one here. So that's the only one at the top there because the next one is beyond our range. But we've also got minus 24 degrees. So minus 24 is going to be around about here somewhere. So again, we're after that value and that value. So I'll leave you to finish that one off, and hopefully you'll come up with the following solutions. So t equals 90 degrees, 204 degrees, or 336 degrees. So now have a go at some of the exercises in the textbook. Around about page 333, something like that, I think, or 323 is it? But the exercise on trigonometric equations, and then the textbook, the assignment questions as well.